So part A, we wanted to find the volume of the water in a tank. Volume. Volume is given by length times breadth times height, since this is a cuboid. So volume. And then because they wanted it in cubic meters, so some of your friends identified that, hey, this 50 cm, we need to do something to it. So Nora, since you came in after me, what should we do with the 50 cm? Yesterday, we established that we cannot just take 2.8 meters times 50 cm times 1 meter to get the answer in cubic meter. So what do we have to do for the 50 cm? Nora, what do you have to do for the 50 cm? Then after Nora answers, Marilyn, your next question will be, what do we do with these three numbers? So Nora, please carry on. Ryan, keep your iPad. No. Come, quickly, quickly. Otherwise, we have not enough time to do our revision. We're going to do revision. What should we do with 15 cm? I want it in cubic meters, but this is in meters, this is in meters, this is in cm. Change to meter. Okay, can you change it to meters for us? How much is it? .5 meters. Okay. Now, Marilyn, Nora has managed to change it to 0.5 meters. What do we do with these three numbers now? Find the volume. What should we do? Three numbers: 2.8, 0.5, and 1. Okay, thank you. Okay, we got a correct answer now. It is 1.4 cubic meters. This is the amount of water in the tank. Now the water is used to fill 0.2 liters container. How many containers can be filled completely? So now yesterday we talked about the shortcut. Have you memorized the shortcut? 1 cubic meter equals to 1,000 liters. We can use this to shorten a lot of our working. So human, 1 cubic meter is 1,000 liters. What about 1.4 cubic meters? How much would that be? What about 1.4 cubic meters? How many liters would that be? 1,000? 1,400. Okay, how do you get 1,400? Which is correct, by the way. How do you get the answer? Talk to me, talk to me. How do you get 1,400? Times, okay, what times what? What? What do you get? 0.008. You want to bring a book here? How do you get 1,400? Yeah, okay, so 1.4 times 1,000. What were you saying just now? Pay attention, you're not even looking at the screen. So 1,000 times 1.4 to give us 1,400 liters. Okay, thank you. So one container is 0.2 liters. How many containers required? Number of containers, 1,400 divided by 0.2. So 7,000 containers. It is the same as that swimming pool of water, divide into little containers. Same. Total amount of water divided by the capacity of one container. So next one, question 6, metal cube. The keyword is a cube. Look, there's no diagram. So you need to know what a cube looks like. Cube has all equal sides. So it looks like this. The volume is 800 cubic centimeter. 480 of these cubes are used to make a sculpture. Find the total volume of the metal cubes in cubic meter. So total volume 800 times 480. Because one of it is 800 only. So multiply by 480. You have 384,000 cubic centimeters. So all these are used to make a big sculpture. Find the total volume, but they want it in cubic meters. So you need to change. What is 384,000 cubic meters in cubic centimeters in cubic meters? Okay, so yesterday we did this. Shabil, let's see whether you can still remember, because I remember you learned it yesterday. Okay, so let's try. From cm, if you ignore the cube, from cm to meter, what should we do? To go from cm to meter. Times or divide? You only have two options, times or divide. Cm to meter. Shabil, what's your height? Shabil is 1.78 cm. Oh, meters, okay. Meters. How much is it in cm, Shabil? Oh, how come you can do it so quickly? This is correct, huh? You know your height in meters and cm. Surely you know how to convert. So, Shabil, how do you go from cm to meter? How do you go from 178 to 1.78? What should you do? From cm to meter. 178 to become 1.78. What should we do? Multiply or divide? What goes to the red arrow? Multiply or divide? 178 to 1.78. Times, okay. Times what? Times 100. Take out your calculator now. Take out your calculator now. Press 178 times 100. Have you finished pressing 178 times 100? Oh, is it correct? No, it's not correct, right? Okay, so what should we change? Let's change it to divide. Now you press. Is it correct now? So how do we go from cm to meter? Times. From cm to meter times. Divide. Divide by what? Okay, now you got it right already. So from, back to this question, from cm to meter, what do we have to do again? Divide by 100. However, the question is in cubic meters. Cubic centimeters to cubic meters. What should we do? Should we still divide by 100? Or do we need to include something? Just not cm to meter divide by 100. Now cm cube to meter cube. Do we still divide by 100 only? What should we do? Add a cube. All right. So use your calculator again. 384,000 divided by 1 million. You get 0.384 cubic meters, and that's the answer. Question 7a. Find the volume and the total surface area of each of these solids. The first one, the solid is made of 5 identical cubes. Let's start with the volume. So how many cubes can you see? Count. Nazreen, how many cubes are there? 5. What is the volume for 1 cube? Nazreen. 1 cube. ACM is the length. I want a volume. Volume. Marilyn, what do you say? Divide. Marilyn, can you help him how to find the volume of 1 cube? Wait, before you help me, Marilyn, you know how to do or not? Then you go over without knowing how to do. Just now we talked about the volume of a cuboid, right? You took 3 numbers multiplied by each other, isn't it, Marilyn? It's the same. For one of these cuboid, for one of these cubes, it is 8, 8, and 8. So Marilyn, do you know how to find the volume? No, do you know how to find the volume for one of this cube? What times what times what? Okay, later you go and tell Nazreen why. 8 times 8 times 8, so 8 power 3. That is the total volume. So we get 2560 cubic centimeters. That's the volume. Now, total area. You can go and count the number of squares, or you can go by the different views to find out the number of squares. Okay, so let's talk about the front view. If your eye is over here, you're looking this way. How many squares do you see? 1, 2, 3, 4. You see 4 squares in front. You see from the back. From the back, you see the same 4 squares. So we currently have 2 times of 4 squares. 2 times of 4 squares so far. Let's look from the side. Look from this side. How many squares do you see? No, 1, 2, 3, 4, 5. Sorry. The front view was 5. I count wrongly. Then from the side view, we count that there are 4. Side view, 1, 2, 3, 4. If you look on the other side view, you also see 4. Where are the 4? 1, 2, 3, and 4. So that is another 2 times of 4. So we have the front, back, side, left with top and bottom. Top and bottom, how many squares? Let's start with the bottom, which is easier. Bottom up, you see 2 squares at the bottom. Top down, when you put your eye on top, you look down, you see 2 squares again. 1, 2. So total, we have another 2 times of 2. This, so far, these are our total number of squares. Total number of squares. However, I need total area. So I still need to multiply this by the area of 1 square, which is 8 times 8, 8 square. So find everything out. 10 plus 8, 18, 18 plus 4, 22, 22 times 64. 1408 square centimeters. Then this is our area of 1 square. One 408. Why? Wrong way? Second last question. All right, yeah, okay. Last question now. Part B, the final question in our workbook. Again, volume. Let's find the volume for the cuboid at the bottom. Okay, I do it. 3, 10, 15. This is the volume of the cuboid at the bottom. We still need to add the volume of the cuboid on the top. Plus 3, 6, and 10. So we have 630 cubic meters. You see that volume is easier to do than area. Volume very easy. Just 3 numbers multiply, add. Whereas for area, it requires you to look at what are these view, that view, up, down, left, right, front, back, which is what we have to do. So here, total area. Let's start with the front. Front view. Put your eye over here. Look this way. What do you see? One rectangle here, another rectangle over here. So in total, these two rectangles look like this, where we have a height of 3 meters. The remaining is 6 meters. This portion is 10 meters. So the total area for this shaded portion is 10 times 12. 10 times 9. 6 plus 3 is 9. Times 2 or what? So fast. Okay, give me a moment. So this total area is 10 times this 10 times the height, which is 9. So Indra says that we should multiply this by 2. Why by 2, Indra? Which side? The back. The back is the same rectangle. Where is the back? Let me shade it in red for you. So the bottom one. The bottom. Same as well as the top. It is the same. So instead of doing it again, just multiply by 2. So that is the front and the back. So we go to the side now. Side and side. What will we see if we put our eye on the side? Look this side. You will see blue color. This rectangle. Yeah, and the one on top. And you recognize that it's the same over here. So later on, we just multiply by 2 again. So let's start with the rectangle at the bottom. We add the rectangle at the bottom, height of 3. 3, the length, 15. And we still need to add the rectangle on top, which is given by 3 times 6. Okay, so this is the blue color one, only from one side. If you want to add by itself, yeah, you can. You can do the plus 13, 15, plus 3 and 6 again. For the other side, left side, right side. Or you can just multiply by 2. Both ways are okay. Finally, we have our top and bottom. Let's start with the bottom. You put your eye over here. This is what you will see. One big flat rectangle at the bottom. So we add 10 times 15. But what about from the top down? From the top, you look down, you see one rectangle over here, as well as this rectangle. And if I were to draw it out, it is actually the same. From the top down, you see this portion, followed by this portion. Distance is 3 over here. And you know what? We don't need that 3. The total is 15 already. And this is 10. So 15 times 10 again, multiply by 2. Get the total area. .606 square meters. That's all.